Hello everybody, and welcome back to my channel, which seems to be mostly amplifiers recently. And this is a Mission Electronics Cyrus 1 amplifier, and again it was sent to me very kindly by Mike, aka Racing Demon, and very kind of him to keep shipping these amplifiers over. It must have cost him a fair bit in money now for the 3 different things he sent me. And a little bit of a story behind this one. This was not the one he was going to send me. He had another one, but he had a broken plastic case and he was trying to repair it. And what did he do? He drilled through the sides and he went straight into the mains transformer. That sort of thing can ruin your day when you do something like that, because then you've got a useless amplifier, unless of course you can get another mains transformer, and I think it wouldn't be too hard to get one, because it's only got 2 windings, 22 naught, 22 volts, 100 VA. So I wouldn't have thought it'd be too hard to find a transformer for the one he's destroyed. But that's beside the point. Let's have a look at this thing. Very Spartan on the front. Probably the most Spartan amplifier I've ever come across. All we've got really is a volume control. We've got a listen control, in other words an input selector. Bit of an odd term, listen, but whatever. And we've got a record control, in other words you can select what input you want to go out to the record outputs on the back. So I suppose in theory you could be listening to one source while recording off another input onto your tape recorder. But that's the sign, that's what it's all about anyway with this thing. No tone controls, no balance, which I find's a bit, well, it annoys me slightly, because at least it should have had some balance, I would have thought. And I do like a bit of tone control myself. As I'm advancing in age, I like to boost my treble a bit, and I also like to boost my bass a bit now and then. So I'm not really keen on amplifiers without any bass or treble, but that's just the way this was made, so we'll have to put up with that. So let's just have a look around the back of it. So it's a slightly unusual way of arranging all this. Normally you'd have the connectors coming out the back of the amp, but there's no reason why it shouldn't be done this way. On the left we've got the speaker outputs, which I don't really like. Banana plug sockets. I much prefer screw terminals, and when I was testing it inside I just had to stuff my speaker wires into there, because I haven't got enough banana plugs to go around. Hardly ever use banana plugs these days apart from power supply connections. Then we've got a headphone output here. By the way, it's made in England, I think in around the early 80s, this amplifier. Then we've got a tape output, standard sort of thing, tape input, tuner input and CD input. So that would date it to at least 83ish, I would think. That's when CDs came in, from what I remember. Then we got a phono input with switchable moving magnet or moving coil. And on the back down here we've got IEC socket, maximum power consumption 100 watts, 240 volts. So I think the best thing to do, have a quick look at the specifications for this and then wire it out and test it. Right, so we've got continuous power, 25 watts a channel, I presume that's RMS into 8 ohms, or 40 watts into 4 ohms. Distortion 0.005%, 1 kilohertz into 8 ohms. That might be a difficult one to measure, because when I did some tests yesterday on my HP audio analyzer, I couldn't read lower than 0.03%. But if it's worse than 0.03%, then I will be able to give a reading on that one. But there you go, that's another one there for 4 ohms. Now this one's interesting. Frequency response line input, minus 3 dB points, 1 Hz and 50 kilohertz. Now I'll be very surprised if it's only 1 dB down at 1 Hz. I have come across amplifiers in the past. I had a Sansui here, beautiful amplifier. I wish I hadn't sold it. And that had a virtually flat response down to 5 Hz. I think it was flat all the way down to 5 Hz. So that was, but I'm a bit suspicious of minus 3 dB at 1 Hz. 50 kilohertz I wouldn't be surprised at all. And then we got the frequency response into the phono inputs, which is 20 Hz, 20 kilohertz, 0.2 dB. I can't test those inputs because I haven't got a reverse RIAA curve filter. So there you go. Damping factor. I'm still not really sure what damping factor is, so we'll forget that one. Slew rate. I do know what slew rate is, but I don't have a way of measuring that easily. And sensitivity 1 watt output for 65 millivolts on the line input. Whatever. What else we got? Maximum output voltage, tape out is 11 volts. Signal to noise ratio at 1 watt output. I can probably test that. My audio analyzer does that. So that should be 60 dBA. So I'll get on and test that later on. So that's the specifications, and we'll be doing that in a minute. And this is the schematic of one of the power output modules, power amplifier output modules. And it's a fairly conventional class AB. And the one thing that I find a bit mystifying though is the output transistors, which are here and down here. They're labelled PT7, and that is their type number. Now I've never come across a transistor with PT7 on it, but what the hell, we'll see when I open it up. And bias adjustment is here, and the thing that bothers me about the bias is, when I go to another piece of paper, right, I got all these figures I want to check. Regulators, it's got some regulators that regulate the unregulated down to 18 volts for the preamp. I have to check that one out. It uses LM317s and 337s to do that, because this is about 30 volts on the unregulated. Now the bias, it says, should be set to between 8 and 20 millivolts. Well, that's a bit of a wide range of figures. It's not what you normally expect when you're given the instructions of how to set the bias. And that's measured across a 0.2 something ohms, 2.4 something like that, ohm resistor in each channel. But with those figures, if you do the calculations, that's a current for those resistors and the output transistors ranging at 8 millivolts, 34 milliamps, and 20 millivolts, 85 milliamps, which is a fairly big swing, isn't it? So I don't know what the hell to set it to. I might set it to about, I don't know, 10 millivolts. It depends how well they're matched. If they're fairly well matched on the two channels, between those two figures, I won't adjust it at all. So I think the best thing to do now is to connect it up and do some measurements on it, and then have a look inside it later on and then take it in the house and play some music through it. Okay, it's my fairly standard setup. I'm sticking in 1 kHz with a volt RMS, and I'm going in on the CD input, which is, I could have used any of the inputs apart from the phono stages. And on the back over there I've got me 2 8 ohm dummy loads, both connected to the oscilloscope, and also one is connected to the HP audio analyzer. So I'll go over to the scope and get that in screen. Now I'll just crank up the volume to see where we get some distortion. Looks pretty good so far. That's reading 10 watts so far on the audio analyzer, and it clips about there, more or less symmetrically on both channels. Quickly up to the audio analyzer, 29.84 watts. I'd say that's pretty good. For an amplifier that was rated at 25. So, squeaking camera as usual. But yeah, what's it say, 25 watts a channel into 8 ohms, continuous. So 29 is not too bad, I'd say. Because I wouldn't run it flat out like that all the time. It wouldn't last long probably if I did. What have we got to do next? Distortion. Okay, let's go up to the audio analyzer. It doesn't really say. That's the wattage at the moment. But if I set it to about, it doesn't really say what distortion, what power output, but that's 10 watts. Right, let's switch to distortion. .02, and what should it be? 0.005. Well, as I said, it's probably my measuring equipment which can't go any lower, but that sounds pretty damn good. If I do crank it any higher, I'll look at the scope and see what it gets like when it gets to the peak. That's the maximum, and yeah, it drifts up then 0.23, just below clipping 0.02. So at 30 watts it's still only 0.02. So I think that's a successful test. And now we'll do a frequency response test. What's it say about that? What's it say about frequency response? It doesn't say what power to do it at. So let's check what power I'm on. That's 9 watts. Let's crank it up to 10. And a bit, whatever. And right, back into AC level. So that's the voltage coming out, 1 kHz going in to the amplifier, or out of the amplifier. And so I switch to distortion. No, I'm not doing distortion. Bloody AC level. That's what I'm doing. Now I want to set that as my reference level at 1 kHz, which I shall measure in comparison to that. So stick in ratio. That's set at 100%. Then go to log, and that's your reference level 0 dB. So let's go down in frequency first of all. 900, 800, 765, 400 Hertz, 200 Hertz, 100 Hertz, and 0.16 dB down. 90, 80, 70, 60, 50, 40, 30, 20 Hertz. 0.2 dBs down at 20 Hz. I'd say that's pretty damn good. Let's see if we can go any lower. So 19 Hz? Alright, 19 Hz. Let's drop it down to 10. That's 10 Hz. 0.3 dB down at 10 Hz. And what are we looking for? Minus 3 dB at 1 Hz. Even so, 10 Hz at 0.3 dBs down is pretty good. Let's go down even more. 5 Hz. Minus 1.5. And 4, 3, 2, it's 1 Hz. Having problems measuring that. Probably because it's out the range of the audio analyzer. 2 Hz. Yeah, it's not reading very well down there. But 3 Hz. I'd say it's round about minus 3 Hz. It's still very good though. That's extremely good. So I'm going to go back to 1K. And I'm back to my 0 point again. And now I'm going to take it up. See how high it goes. That's 5K. Dropping off a bit. 10K. Minus 0.3. 12, 13, 14, 15. Minus 0.5. Okay. 20K. Minus 0.65. Still pretty good though, pretty flat. Okay, let's go up in bigger intervals now. 30K. Minus 1. 40K. Minus 1.7. 50K should be down by 3 dB. And it's doing better than the specification. Minus 3 dB, it should be at 50K. I can just do that. 60K. Yes, it's well within the specification at the high end, and probably is at the low end as well. So, pretty pleased with that. It's a pretty flat response. Sorry, I'm just drinking coffee at the same time. We're down the wrong way. What am I going to do now? I'm going to do I'm going to do signal to noise ratio at 1 watt output. So I'm going to go back to 1K. And that's now to do it. Wants me to do this at 1 watt output, so I'm going to go back to measuring watts. 19.0 special, that's 10 watts, so let's crank it down to 1 watt. It's fiddly to get it exactly right. I think that'll do. That's near enough to 1 watt. And let's do this signal to noise ratio. What do I have to do there? Shift. I don't use this one very often. Shift and synode. I know what I'm doing wrong. I can't use my signal generator to do this test. I need to use the output of the oscillator in this thing, because it switches it on and off. It puts it on and measures a level at 1 kilohertz, then it turns it off and it measures the noise and works out the signal to noise. So let me just reconfigure. Okay, so I'm now using the output from the audio analyzer instead of my normal signal generator, and that's the wattage that it wants, 1 watt. So now I'll switch it into do signal to noise, so it's shift. Nah, I don't know what I'm doing with this thing. Hang on a minute. Okay, I had to go back to AC level. Now I can do shift, shift, and signal to noise. Okay, it's done its measurement. 81 dB signal to noise, and on the line input it should achieve 86 dB. That's not too far out, is it? Let's just do it again, just for something to do. How do we do this? Back to AC level. Shift, signal to noise. Yep, same, 81.7. So I think that's fairly good. Right, I think then might have a quick look inside of it. Oh, by the way, when it's as I said, it's pulsing this signal on and off. And if you look down at the scope, that's how it's doing its measurement. It's turning the signal off, on, and measuring the level, and then it's turning it off and measuring the noise. That's how it's doing the signal to noise ratio. So I think now we'll disconnect all this rubbish and have a quick look inside. Okay, got a top off, and it's rather sadly it's a plastic case. I would have liked to have seen a metal case, because along there you see it's fractured when the screws have been put in. That's a bit sad they couldn't have put a metal top on it, because that's very vulnerable to breaking. But if we have a look inside of it, maybe turn it. Lost my pointer. Oh well, I'll have to use this one, which is metal, which I don't want to do. No, I don't know where it's gone. Where's my bloody pen gone? Let's use a yellow one. There's the power output, transistors. Can't quite read what it says on them. They got Cyrus numbers on them, which is interesting. If I zoom in, probably won't be able to see, but so they must have had their own transistors made, or printed anyway. Cyrus PT7. So, interesting. Heatsink's a bit small. Would have liked to have seen a bigger heatsink, because that was pretty bloody hot after I was doing those tests. Nice big block of aluminium, but it could have done with a few fins to cool it down. Next thing I want to know is, how do I adjust the bias? And where do I measure the bias even? I'm pretty sure there are two 4.7 or 2.47 resistors in parallel, and that would be this one or this one or this one or this one, yeah, on each transistor basically. So I'm going to rig up some connections and do a measurement across those resistors. Okay, I've got my crocodile leads which go to my meter across one of those output emitter resistors, I should say, and I couldn't find the potentiometer to tweak it, because if you look up here I'm only getting 6 millivolts, which is below the 8 they recommend. But then I had a look around and there's a little blue thing, and that's the adjustment, so you got to get in at that angle. So what shall I adjust it to? I don't know what to adjust it to. maybe 10 milliamps, as it's not, doesn't seem to be that critical. 10 millivolts, I mean. So, get my bloody thing in here. Well, I reckon that's turned all the way up, so if I turn it the other way, you get bugger all. I've got the wrong tool really for doing this. Oh, 24 millivolts, right, weird. Must have been noisy pot maybe. So I'm going to stick it at 10. And it is very warm at the moment, the heatsink, so it's the ideal time to do it really. And let's go over to the other channel then, if I can do it without blowing things up. Right, that's on the other channel. Don't know if it's left or whether it's right, but whatever, it doesn't make much difference. And yeah, got nearly 10 milliamps, 10 millivolts. I mean, this value will vary constantly when it's warming up and cooling down. I think that's more than good enough, 9.9 millivolts. I mean, I could set it to 20 like it said, but better to keep it a bit cool, I guess. Needs a bit more of a tweak maybe. Right, that'll do for that. Okay, I was going to check the voltage regulators which are down there. There's 2 voltage regulators. Go back to the meter. Get rid of these clips. Put the negative on there and positive. That's the input to the voltage regulator, obviously. 16.7, supposed to be 18, but I suppose it's not going to make a hell of a lot of difference. Let's try the other one on the other supply, and that's 18.1, minus 18.1. Right, I think I had the wrong pin there on the other one. So they're both fine, they're both 18 volts, just not a problem. Now, what else is to say about it really? It looks a nice design, fairly well made. What's it got down there? Got some 10,000 microfarad, that's a pretty good decent sized capacitor, and I'm sure they are good, because big capacitors like that, they do not tend to go faulty in my experience. And we've got a nice big toroidal, which is the one that obviously Mike stuck his drill through. So, poor Mike, he must have been so upset. But anyway, that is about it really. I think what I'll do now is put it all back together, take it in the lounge and stick some music through it. Okay, here we are back in the lounge. Not sure where the cat's gone, so I won't be upsetting him if he's gone somewhere else. Hopefully he has. And what I'm going to do is I've connected it up to my CD player over there, and it's connected also to my Celestion Ditton 44 speakers, one over there, one over there. And the track I'm going to play is off this album, Rinky Dink Mobile Bicycle Powered Sound System Live. No, I've never had a problem with this. I've been told it's copyright free and I haven't had a problem so far. And just for change, I'm going to play this track here, Big Money. So let's just start it up. Of course you won't get the full benefit, like I can hear it here.
Big money, and your bowler hat. You look so meek to me, and yet your empire's grown. You look so meek to me, and yet your empire's grown. You inherited the material world. You inherited the material world, yeah. Soldier got conscripted in a search uniform, mistreated with a helmet and rifle. You make me weep to those with that on. You make me weep, yeah. Yet you vote for Yet you vote for the material world, yeah. Immortality, measuring worth by a salary. You're never considering the ecology. Push up in the collection of money. One after another, say no catastrophe. On and on, what's the remedy? The divine spark is a continually. Whatever they do to me, it's a mortal body. All the same in the personality. We all leaves upon the same tree. Yeah.
Okay, I think that's probably enough of that. As I said, you won't get the full benefit over YouTube, and also I'm using a fairly cheap and nasty camera, but all in all I think it sounds extremely good. I think it sounds better than that other one I did, the Cambridge A60, and I shall be using this for a bit just to try it out. There's loads of volume there, and sounds really clean, and plenty of whatever you need out of an amplifier, and well, I'm quite happy with it. So I hope you enjoyed the video on the Cyrus one. Thanks for watching, give me a thumbs up if you dare, and bye for now.